Hello, everybody. Welcome to the Junior KPSNA Science Fair. We have some amazing participants. We have 14 of them this morning, and they're all giving me subjects, and it looks really, really amazing, and I can't wait to learn a lot about science this morning. So we're going to start without further ado with Sanvi Amrutya from California. She's going to show us leak-proof bag experiment. Sanvi Amrutya from California. Is Sanvi here?
Yes, can you hear me?
Yes, dear. Are you, okay, let me make you. Okay, Sanvi, hello. You can, all of the kids, you can introduce yourself again with your age and maybe if you want to say which school you go to and then go ahead and start your project. Sanvi Amrutya.
Hi, my name is Sanvi Amuthia and I live in California, Yorba Linda. My school is Glen Knoll Elementary and I am 8.5 years old. My experiment is a leak-proof bag. You need a bag filled with water, sharp pencils, and a bowl, and a napkin in case you spill. So what I'm going to do is I'm going to take my pencil and I'm going to hold my bag really tightly and I'm going to just poke. And what should happen is it shouldn't leak. Is it leaking? It's and then I'm going to try another pencil. So that is how the leak-proof bag experiment works. It works because the leak-proof bag experiment works because the bag is made of polymers. Polymers are very flexible. So when the pencil pokes through, the polymers flex. So what happens is when the plastic is holding the water, which is hugging the pencil. Thank you for listening to my experiment. And we're good at, so if you have any little brothers or sisters, you can show it to them as magic. Like, look, the water does not leak out. Thank you for watching my experiment. Goodbye.
Good job, Sanvi. Awesome job. Okay, that was really nice. So next we have Nihar Dadania from New Jersey. He's gonna show us the egg experiment.
Hi, my name is Nihar Dadanya. I am in New Jersey. I live in Voorhees, and I am 10 years old. So I will be doing an egg experiment. So here I have a cup, like a Starbucks coffee mug thing, piece of paper, a lighter, and a boiled egg without the shell. So if I just put the egg in, it will not fall through. See, it is staying there. So it will not fall through the cup. But if we put a piece of paper in it, Neve's going to light it. Right. Okay, now we have a fire in the cup, mug. Can't see it that well, but there is
It
one.
went out. It went out.
Okay, wait, it was a sec. Should put a wick in there. Okay, so there's a fire. Okay. So we put the egg in, and not working. Why?
No, because it's not lit inside.
Right.
Hmm.
The fire is not.
It has to be lit.
The fire is not lighting. I'm looking.
It's not working.
Fire is not lighting.
Just put it in.
I put it in and it should fall through. but
Can we keep the camera a little up? We can only see half of the egg. Yes. Little more.
yeah.
Yes, now we see it.
So the egg should fall through, but
Let's
for
put
some
this-
reason it's not.
Yeah.
So
Let's just use the.
yeah, we're just gonna need to use a
That will
match.
flare.
Okay. We need to drop it in. Okay. Drop it in. Drop it. Now we're gonna put the egg in. It should fall through, but it's
Fire-
not
it's
falling
not-
through.
No.
So we're having an issue with our egg.
Now.
That egg. No, you can try one more time, Nihar. Give it a try. It's a nice experiment. Give it a try.
Because we tried it before and it worked. But now it's not working for some reason. Like it's not falling through.
No, it's not gonna work.
Yeah, it should fall through,
Because the
Because
thing
the
is-
pressure-
for one- let me try this.
but it's not falling through
Have it
anymore.
ready. Put your leg.
Maybe the cousin can do her magic. Can cousin do a magic, little cousin?
I think it will do.
So yeah, it should be like changing the pressure inside the fire. It should be lowering it. So the higher pressure outside will force the egg through. But for some reason, the fire keeps going out, so the egg doesn't get forced through.
What my guess
so it
is
should flick fall
the
through.
fire is using up all the oxygen that's in the bottle, and it gets sealed up by the hard-boiled
Yeah.
egg, and so it can't stay on fire anymore without any fuel.
Yeah, we got it through.
Yay.
We pushed it through. That's what it should do, but for some reason it didn't. So that's the boiled egg in a cup experiment. I hope you try it at home and see if you can get it to work.
Awesome, Nihar. Thank you so much. Next, we have Ria Macaria from California, San Francisco, and she's gonna show us the life cycle of a frog. And she's gonna go to school in a few minutes. That's awesome, Ria. Thank you for joining us today.
Thank you. Hi, my name is Ria, and today I'm going to tell you about a life cycle of a frog. First, a female frog lays eggs. It lays eggs in the water, and it lays hundreds and hundreds of eggs, but only a few survive because of rain, wind, and other things, including animals like ducks, fish, and insects, which eat the eggs. The eggs are surrounded by a jelly-like thing that protects it. Then the egg hatches out into a tadpole. Tadpoles look more like fishes than frogs. The baby tadpole comes out of the jelly sac and then eats that jelly sac for food. The tadpole swims around in the water, and it has a tail, and it grows fins and gills. It eats plants and algae. In stage 3 of a frog's life, the tadpole turns into a frog. It looks less like a fish and more like a frog. And now the tail gets smaller and smaller until it eventually disappears. Then the froglet grows forelimbs and lungs. Forelimbs are the front legs, and lungs will help it breathe on land. Then it jumps out of the water and is an adult frog. It looks like a frog. Everyone knows that. And after a couple of years, when it's a full adult, it lays eggs and the life cycle starts again. Now I'm going to show you a poster. So this is eggs, because it's eggs. And then in about 3 weeks, it becomes a tadpole. Tadpoles will eat algae, will start to eat algae, swim, and will socialize with other tadpoles. Then in about 6 to 9 weeks, it will become a froglet. And it looks like a frog with a tail. And then it starts to eat insects and plants. And then in 12 to 16 weeks, it becomes an adult frog. Since frogs are amphibians, they live on land and water. And I'm 7 years old. I hope you enjoyed my speech. In
That
12
was beautiful.
to 16 weeks, it becomes an adult frog. Since frogs are amphibians, they live on land and water. I'm 7 years old. Thank you.
That's awesome.
I hope you enjoyed my students.
It was very fun. Thank you, Ria.
Beautiful.
Since behind an adult box, since frogs amphibians and
Is it Ria still talking or? Yeah, okay.
Oh, I don't know where that's coming from.
I know, I thought it sounded like
Awesome.
Ria.
It was very fun.
Okay.
When Kamaru
Now
used
we
Spanish,
have-
right?
Can everybody please mute themselves?
Oh, somebody's
Yeah, it
YouTube
sounds
live
like
must
it, but-
be running.
Oh, I don't know where that's coming from.
That's okay.
No, I thought
Doesn't show where it is coming from, but yeah, looks like from yours, Khushbu.
ખુશ-
Yeah, it was from yours.
તમારો ક્યાંક YouTube live ચાલુ છે.
તમારે કઈ બેકગ્રાઉન્ડમાં કઈ ચાલુ છે somewhere. And
YouTube live ચાલુ છે તમારા ફોનમાંથી અથવા કોમ્પ્યુટરમાં તમે.
બંને ફોન બાજુમાં નથી ચાલુ ને કઈ?
Okay, sorry about that. We're just figuring out how to record it the best way so everybody else can watch it. So next we have Asha Kalaria from Maryland, and she's gonna build a rocket. Asha, take us to the moon.
Not yet, let her say.
So my name is Asha Kalaria, and I'm 8 years old. And rockets are important because if we didn't have rockets, then we wouldn't be able to see space and explore it, basically. And I did a video of how I built a rocket, a model rocket.
Just double click. Yeah.
Oh,
Can you move that?
yeah, just move it. Oh, yeah. Sorry. Okay. What? Wait. It's. Oh.
rod
Wait,
sticks.
let me.
There you go.
Today I will be making a model rocket kit. And first, I laid everything out, and I'm going to assemble these rod sticks. The first step was assembling the launch rod, and I just did that. Right now, I'm gonna continue building the launch pad, and I'm gonna put this red deflector plate in, and then I'm gonna turn it to snap shut. And what this does, it makes sure that the ground doesn't run on fire. We are going to make the launch pad by snapping the launch pad base together, making this triangle shape thing. So I put the launch rod into the base, and right now I'm going to slide the deflector plate on and to the bottom. So now that we have built the rocket base, I'm going to take the engine holder and put it on the fin for the rocket and put the adapter holder on the rocket. Right now, I'm going to glue the lug to the rocket like this. It sticks. And then this way, it'll be able to go down like this and be able to launch it. I'm going to take the shock cord and I attached it to the rocket. And then I'm going to take the shock cord, and on the other end, I'm going to take it and tie it onto the nose of the rocket. So I'm going to take the parachute and fold the nose, and then put the other edges together to make this silicone thing. Then wrap the rest of the string around. Then stuff it in to the rocket. I'm gonna put the decals on like this, and when I do, it'll stick. And I'm I'm gonna take the igniter and put it into the engine and take the plug and plug it in. Then I'm gonna take the engine, put it into the rocket, and then slide the rocket onto the cord. And then we're ready for takeoff.
And yeah, that was my model rocket.
How do we stop? Oh.
Yeah.
All right, so that was the model rocket.
Yeah. It was
That was really fun, Asha. Next we have Jill Viramgama.
Hi everybody, my name is Jill Verangama and I'm from Maryland, and today I'm going to be doing a PowerPoint presentation on plant cells. Okay, so first, just overall about plant cells. Plant cells are unique in the fact that they are the only known things on Earth that can produce their own food by themselves. Plant cells are most known to convert light into food using photosynthesis. The process of photosynthesis produces oxygen that plants give off into the atmosphere. Animals and most of Earth's life depend on the oxygen plants produce to live. Okay. So the plant cell is a whole by itself, but there are many parts to it. On the right to the diagram, you'll see the four main parts. There are many parts in a plant cell, but in the diagram, you will see only the main ones. The parts of a cell all work together like a factory. One part will complete its job, and then the next part will do its job, and so on. When all the parts have done their jobs, the process of photosynthesis is completed, and oxygen has been released. So many times a plant cell doesn't go, like everything doesn't go as planned, and then you have a damaged plant. So on the top left corner, you'll see a healthy squash plant and its leaves. And then on the bottom of that, below that is what that will produce. But on the top right corner, you'll see a damaged plant leaf. There's yellowing and there's browning, and there's also holes in the leaf. Below that is what that will produce. That kind of plant is not ideal for anything. You can't cook, you can't eat, whatever. Most of the time when plant cells get what they need, they succeed at doing their jobs, and therefore the plant turns into a vegetable or flower and it stays healthy. However, when part of a plant cell fails to do its job, gets infested, or it gets damaged, everything gets messed up and nothing is produced. Now back to the four main parts of a plant cell. The first part is the cell membrane. To the right is a picture of the cell membrane under a microscope. The cell membrane is composed of a thin layer of protein and fat. It plays an important role in regulating the entry and exit of specific substances within the cell. For example, the cell membrane keeps toxins from entering inside while nutrients and essential materials are being transported. The second part of a plant cell is the nucleus. The nucleus is a membrane-bound structure which stores the cell's hereditary material, or DNA. It also coordinates the cell's activities, which include growth, protein synthesis, and reproduction, which is known as cell division. In a plant cell, the nucleus is located more on the periphery and the center of the cell. The third part is the cytoplasm. Now on the picture to the right, the cytoplasm is actually only the clear jelly-like liquid. The green part isn't part of the cytoplasm. The cytoplasm is a clear, thick liquid that fills the insides of cells, and it is located inside the cell membrane. It contains molecules such as enzymes, which are responsible for breaking down waste and help in metabolic activity. The The cytoplasm is responsible for giving its cell its shape. It helps to fill out the cell and keeps organelles, which are organized special structures within a living cell, in their places. The fourth and final part of the main part of a plant cell, is the mitochondrion. To the right is a picture of the mitochondrion under a microscope. The mitochondrion is a membrane-bound organelle found in the cytoplasm of cells. It is the powerhouse of the cell and is responsible for cellular respiration and production of ATP, which is short for adenosine triphosphate, in the cell. Now, the final thing is how human, plant, and animal cells are alike. On the top row, you'll see pictures of a human cell, an animal cell, and a plant cell up close. Plant, animal, and human cells are similar in many ways. All three types of cells have many of the same parts: the mitochondria, nucleus, and cytoplasm. Humans, animals, and plants also contain DNA that is made up of the same building blocks. However, the main way that they are similar is that you must take care of them. With plants, humans give them water and place them in sunlight to grow. This allows the cells to stay healthy and full of nutrients. Likewise, we need to take care of our bodies by eating healthy, drinking lots of water, and exercise. Remember, a healthy life is a happy life. Thank you.
That was a very good information. Now we know which plant to eat and which one doesn't. Thank you so much, Jill. Now we have Daria Harshad Viramgama from Texas. He's gonna show a plant that he grew without soil.
Can you hear me?
Yes, we can.
Okay, I'm gonna share. Okay, can you see the screen?
Yes, we can.
Okay, so good morning, everyone. Today I'm gonna be talking about growing plants on Mars. So, a million humans could live on Mars by 2060, as said by Elon Musk. Now, why do we need to go on Mars? Remember what happened to dinosaurs? One meteor hit Earth and boom, finished. Not a single dinosaur left. Now, we don't want that to happen to us humans. So how do we make sure that humans don't go extinct? We need to become multiplanetary. So what that basically means is we need to live on multiple planets and not just Earth. And why just Mars? Mars, because it has the perfect weather suitable for human life, and the distance from the sun is also perfect, and human life can live there. Now, how do we get to Mars? There are 5 steps we need to achieve in order to get to Mars. So, step 1 is getting there. Now, we've already accomplished this step. As you might have known, NASA has sent multiple rockets to Mars by carrying rovers and other stuff. Now, step 2 is extracting oxygen from carbon dioxide in the Martian atmosphere. Now, Mars has a lot of carbon dioxide, and we need to convert it into oxygen in order to breathe. And there's a method called electrolysis, which converts carbon dioxide into oxygen. Do you know about the rover that Mars sent recently, the Perseverance rover? That is going to test out this method and see if it works, and hopefully we'll accomplish step 2 by 2020. Then step 3, making water from hydrogen and oxygen. Step 4, producing food on Mars. And step 5, building structures on Mars. Today, I'm going to be focusing on step 4, which is producing food on Mars. Now, what is so challenging about this step? So, the soil on Mars is not fertile, and therefore it doesn't support plant life at all. So how are we going to grow plants on Mars without soil? Where there is one way, which is hydroponics. So what hydroponics is it's a method in which you can grow plants without soil. All you need is just water. Now what I'm going to show you is, so I'm going to show you how I grew a plant using hydroponics, using everyday objects. So this is my plant. I hope you can see it. You can see the plant. Okay, so what materials you need for this is a plastic water bottle, some water, a tissue paper, some cotton balls, and seeds. So how do we do this? So start by cutting the water bottle from the top here and place the top upside down so that it makes a funnel-like shape. Then pour some water in the bottom, and then take a tissue paper, put it on one side in the bottom, and make sure it goes up through the open bottle cap. Now, add some cotton balls on the top so that the water doesn't leak down, and then just sprinkle the seeds on top. And now what happens here is the water down here goes up through the tissue paper, reaches the bottom of the cotton balls over here, then slowly goes up and provides the seeds that we sprinkled just enough water to germinate. And now just put it in the sunlight and sprinkle a little bit of water every day on top. And now that's how it works. As you can see, my plant has germinated. And if I keep doing this, it will grow bigger and bigger. So now let's hope that I get to buy a house on Mars by the end of this century. Thank you.
Oh, you better invite the whole KPSNA to your house. We'll all visit you.
Yeah.
Thank you so much. Next, we have Arthur Sania from California. He's gonna show us how to get exercise while you are always on your iPad. No, it's good. You can see it, right? Oh, yes. Okay, let us mirror our screen. You guys all see the writing backwards, right?
No. Yes, we can. We can.
It's
No, we can see correctly.
Okay, I'll flip the mirror. Yeah, go ahead.
Bike generator. These days, have you not been getting enough exercise? Since we're all stuck at home, you probably don't go out and do some things like biking, or maybe not even go on a treadmill. And we're stuck on our devices all the time. But there might be a way to fix this. Instead of when we have to charge our devices just to plug them into the wall, why don't we make that electricity ourselves using generators? So now I'm going to show you the model of a generator I made here, and then I'll explain to you how it works. So the only proof you really have that electricity is actually there is this voltmeter. It's going to go up if we actually made electricity. As you can see, it's going up to around 2 volts. So that's a little bit more than an average AA battery. I can make by spinning that. So how does this work? We're turning circular energy into electricity we can use. It comes from a principle called the Faraday lens law. That says that whenever there's a change in flux near a wire, a current will be produced. So whenever you're near a magnet, like in this picture, a magnet produces magnetic flux. And if there's a change in flux near a wire, then the wire is going to immediately carry a current. So if we put a loop of wire in between these magnets, and we spin this loop of wire, then to the wire it's going to look as if the magnets are spinning, right? So it's going to be a change in magnetic flux, and that way electricity is going to go through this coil of wire. Now what we do to fix this is we add a component called the commutator. What does the commutator do? So if both of our ends of the coil are connected to 2 rings on the commutator, and those 2 rings are connected to brushes, the wire won't get twisted up when we turn the coil. Because each time we twist it, the other ring will be touching a brush, and the brush can still conduct electricity. So the brush won't twist along with the wire, but it's still going to conduct the electricity through. This way, all of our current is also in the same direction, because in the second half of our rotation, the current goes in the opposite direction. And if we switch which coil that's coming from, it's going to go as if it's all coming from the same direction. Actually, this concept has already been made by a company called Hub Dynamo. Hub Dynamo is a ready-made generator which you can mount on your bike. It's so strong it can actually charge a cell phone. And it even costs $200 for a hub, but this is still an amazing concept to learn about, and it's really interesting how we can turn just spinning motion into electricity we can use to do our everyday things. I hope you enjoyed my project.
that was Tanya. So rather than sitting around and doing playing video game on iPad, you get to go on a bike ride and charge your batteries yourself. So you get some exercise as well. Next we have is Gia Canaria from Pennsylvania. And she's gonna show us oil spills and how they affect the environment.
She can't share the screen. Like it says the host disabled sharing. Okay, there we go. All right, can you all? Here, got you. Jim, sit here.
Okay.
If they can see the screen.
Can you see the screen? Yeah. Okay.
You can.
My name is Gia Canaria. I'm in 2nd grade. I live in Branningsville, Pennsylvania. And my project is about save the environment and no more oil spills.
Here.
What did I do? I poured the oil into the water.
Okay. Look, you can show them here. Can you guys see?
Yes, it's good.
Pour more.
Okay. There's a bubble now.
That's it.
There you go.
That's it.
There you go.
That's good.
All right. Can you see?
Probably can see the bubble.
Yeah, we can see the picture. Yeah.
Okay.
Yeah. If you can see in the picture, in the glass, so I poured the oil in, and then on the top, the oil is not mixing with the water because the oil is less dense than the water. So it's just staying on the surface. It's more heavy than the water. What did I find? The oil and water did not mix. The oil was just sitting on top of the water, making 2 separate layers. But why? The oil forms a layer on top of the water because the oil is less dense. How does oil get into oceans or water? Big companies that throw oil in the ocean and leakages cause oil spills. Why is this a problem? Sea creatures could come to the surface of the water, and when the oil is there, they can die. We would like to save them. Thank you for watching. I hope you enjoyed it.
That is awesome, Gia. You were so cute. Your sound was very cute. We would like to see your face too. You want to show your face one time?
What?
Can you make me host again, Alpish Bhai?
Here, I got it. KPSNA USA, and then make host. Yeah.
No.
And you can make me co-host. You don't need to make me host. So.
Okay, sure. Yeah. Next one we have Nihar's brother from New Jersey. He's gonna show us experiment with copper chloride and magnesium. That sounds very interesting.
Okay, so the experiment that I'm going to be performing today is the copper chloride with magnesium and aluminum foil. They're 2 separate experiments, each involving copper chloride, and one will have aluminum foil and the other will have magnesium. So this experiment, I'll perform it first and then I'll explain it. This is the copper chloride. It's very bright blue, but it starts to change colors throughout the experiment. So I'll start with the magnesium experiment. This one is slower, but it still reacts. So this is a magnesium strip that cut to length. And so if you're watching the experiment, if you can see this better, the magnesium starts to boil with the copper and it starts to bubble. And what will happen eventually is that the copper will switch with the magnesium. So the copper will just become copper little things in the bottom of the liquid, and it'll become magnesium chloride. This experiment is slower than the aluminum foil, but there's two ways we can do the aluminum foil experiment. It's either with a flat piece of aluminum foil or a ball of aluminum foil. The flat piece is interesting because once I put it in, it starts to react very quickly, but you can't see anything. But if I take something, move it around and flip it upside down, it's already starting to switch. And so you can see little bits of copper that are on the aluminum foil. And it's eating away, starting to disintegrate. And eventually, I can rip it like tissue paper in water. The ball, however, is different because it has way more surface area. So when I put this in, it starts to react. And then become very brownish, forming a material called copper bronze, which, when it's polished up and collected, it looks a lot like this. It's very gold-like. So as you can see, it's steaming a little bit because it gets that hot. If you can feel it. And it's way lighter on the bottom, so that's why it won't flip. This stuff is very easily malleable, and I can poke this piece of plastic through it. So, yeah, magnesium is still reacting. You should be able to see it bubbling. And so these both are single replacement reactions in which the copper is replaced by either the magnesium or the aluminum foil. And when this happens, either liquid will turn to magnesium chloride or aluminum chloride, and the copper will settle at the bottom. Or in the aluminum's case, it'll form aluminum bronze, and some copper will still go to the bottom. As you can see, you can see that copper at the bottom. That would be it.
All right, Neve, that was very interesting to see the change of color. You see all the girls and everybody clapping. Next, we have Saya Kalaria. She's back from the moon. Her sister launched her on the moon, but she's back. She's gonna show us ice cream making.
Hi, my name is Saya Kalaria. I'm 11 years old. And have you ever, on a hot summer day, been outside and really, really wanted some ice cream, but you don't have any at home? Well, I have a solution for that. I'm going to be teaching you how to make ice cream in a bag. It'll only take around 5 to 10 minutes. To make ice cream in a bag, all you need is a sandwich-sized Ziploc bag, a gallon-sized Ziploc bag, 1 tablespoon of sugar, 1/4 teaspoon of vanilla extract, half a cup of a mixture of milk and cream, and you'll need 6 tablespoons of salt. And for me, I'm going to be using Oreo cookies because I'm making cookies and cream ice cream. And also around half a gallon of ice. Now, to make ice cream in a bag, I'm going to add my sugar to my milk and cream mixture. Then I'm going to add my vanilla. I'm going to add my Oreo cookies. And then I'm going to mix it up with the spoon until the sugar dissolves. Now, I'm going to give the sandwich-sized Ziploc bag to my sister here. And I'm going to pour the this creamy mixture into this Ziploc bag. And you make sure you get everything. Okay. Wait, come here.
It's fine.
Okay. Then you're going to zip it up and make sure you get all of the air out while you're zipping it up. Zip this up. And then I'm going to set that aside. I'm going to take my big Ziploc bag. I'm going to give it to my sister. I'm going to add most of the ice, but not all of it. Very loud. Then I'm going to add my salt.
What kind of salt is it?
Kosher salt.
Okay.
I'm going to take my milky cream mixture, make sure it's zipped up very well. I'm going to put it into this bag. I'm going to add some more ice to it.
Put it down.
And the rest of the salt. And we're going to make sure all the air is out while I zip it up. Then I'm going to give this to my mom to shake it up for around 5 minutes.
Wait, how am I supposed to do this?
Oh yeah, and also you can wear gloves or oven mitts or something. My mom first, so she can shake it up while I explain to you the science behind this. So salt lowers the freezing point of the ice, making the ice melt very quickly, quicker than it would on its own. And the normal freezing point of ice is 32 degrees Fahrenheit, but with salt, it'll be lower than that. When ice melts, it takes the heat away from anything that's around it. And in this case, it'll take the salt and ice will take the heat away from the milk and the cream and all that to make the ice melt. In the winter, when people put salt on the roads, they do it so that the ice and the snow can melt and turn into slush so that you can drive on it. This picture here is a picture of, this is normal water here, and then when it freezes, it becomes nicely packed into like a nice figure. But then with the salt water, it's very hard for it to freeze because of all the salt in between. But when it finally does freeze, it'll be ice and then salt around it. That same milky, creamy mixture and put it in the freezer to see how long it would freeze. It took around an hour to freeze instead of this only takes around 5 minutes. Before this, my mom and me made one that is like already done. So this is the bag. The ice has melted a lot.
I don't know if you can see it.
Yeah, the ice has melted. And this is what the ice cream turned out to look like. It's wet. Yeah, it's wet. But
put it on the tube. There you go.
This is what it looks like. This is what it
Get
looks
more
like. Yeah,
so they can
so
see
you can
it.
see it. This is what the ice cream looks like.
How long did it take?
5 minutes. I'm gonna try it. I want. Tastes very good. And that's all I have to say about making ice cream in a bag. Thank you.
Wow, ice cream, you scream, we all scream for ice cream. You made us all very hungry for some yummy ice cream. Thank you, Saya. Now we have Riva Canaria from Pennsylvania, and she's gonna show us the effect of turmeric on tumorigenesis in planetarium. So, here you go.
I can't share my screen.
Make a co-host.
Okay, sure.
Okay. Okay, can you guys see my can you guys see my screen?
Yes, that's good. We can see it.
Okay, so my name is Riva. I'm from Pennsylvania, and this is a project I did for a science fair, and I just shortened it so I could present it here. So basically, I tested the effect of turmeric, which is just heard there, on tumorigenesis. And tumorigenesis is the process by which tumors form in cancer. So this was my research question, which I just explained. So does turmeric inhibit or slow down tumorigenesis in planaria? Planarians are little worms. I'll show the pictures later. And they're obviously you can't test like these types of experiments in humans. So scientists and researchers use planarians because their stem cells, which is what their bodies is made of, are very similar to human cells. So whatever you test on them will react very similarly to how human bodies would react. So I hypothesized that if there were 3 groups of these planarians, one exposed to the herther and carcinogens, and carcinogens are things that cause cancer. So I basically just gave them like a carcinogen so they would develop tumors. And then one of the groups I exposed only to the carcinogens, so they weren't treated. And then one I just left as a control group so I can measure it compared to the rest. This is like the extensive materials list that I used, and I'm going to explain how I used it in the procedure. So as you can see on the left, there's me, and you see about 9 dishes. It's because I used 3 groups, and each one had 3 dishes in case something goes wrong with one of them, so there's still like a good amount of data. So I just filled them up with water, and I put in the worms or the planarians, and I let them adjust. And then I would expose 2 of the groups to the carcinogen, and then I would just leave it there and let them soak it in and develop the tumors. And after 24 hours, I exposed only one of the groups, so only 3 of the dishes, to the turmeric solution. So I would do this every 48 hours, and I would measure the results. And of course, I changed their water and fed them and everything. And then after recording the solutions, this was my graph of my results. So it might be a little hard to read, so I'm just going to explain it. So it shows that the planarians in the first group, which was exposed to the turmeric solution, had less tumors than planarians in group 2, which was like left untreated, just left there to die. Okay, so these are the planarians. These are not microscopic views, these are just normal views. But if you can see, some of the planarians have little bumps on them, which are the tumors, which could be better seen with microscopic pictures. As it turns out, my hypothesis was supported since group 1, which received the treatment, had fewer tumors than group 2. And I also concluded that turmeric can help prevent cancer and slow cancer growth, but not cure it. Because curcumin, which is the main compound in turmeric and makes up most of it, has well-known antimicrobial and antibiotic properties, which is backed up by this statement in the yellow box. So according to Cancer Research UK, which is a cancer institute, like a research institution, research has shown lower rates of certain cancers in countries where people eat more curcumin. It, referring to the curcumin, seems to be able to kill cancer cells and prevent more from growing. So the benefits of my research to society include benefits in the medical field, the science and research fields, with cancer patients in hospitals, as it can help develop treatments or medicines for cancer that have less side effects, since turmeric is natural and it may be more effective. Thank you for your time and attention. Are there any questions?
Thank you so much. Riva, we're going to take questions towards the end so everybody gets their turn right away, but that was really, really nice. And I'm sure all the kids get to eat herther sometimes when they're sick, right?
Yeah.
Mom gives you herther on a spoon. So that was amazing. Next, we have Arna Dosania from California, and she's going to talk about refraction.
Hi, my name is Arna Dosania, and I'm going to show you an experiment Hi, my name is Arna Dosania, and I'm going to explain it or show you an experiment to explain the important principles of physics. First, you need a glass of water. Both arrows are facing the same direction. So look what happens if I put them behind the water. The arrows flips direction. But why does this happen? This happens because of something called refraction. But first, how do we see things? We see things when light waves bounce off an object and into our eyes so we can see it. But when light waves switch medium, they bend. So when the light wave bounced off the paper and went into the glass, which is a new medium for the air, it bended. And then it went into the water, so it bended again. And then into the glass, it bends. And then in the air, it bends again, it comes into our eyes. Why does the image flip just because it bends? Because as the light waves bend multiple times, the image starts to flip. But why does it bend more in glass, less in water, and even less in air? That's because glass is more dense than water, and water is more dense than air. So basically, the denser the new medium is, the more it bends. There are three phenomena of light, and refraction is just one of them. Let me tell you a little bit about the other two. First is reflection. Reflection is when light bounces off a surface in a right angle. Then comes diffraction. Diffraction is when light goes through a small slit or hole, and when it comes out, it spreads in all directions. Those are the three phenomena of light. Thank you for listening.
Thank you so much, Arna. That was amazing. We have our last two kids, and that one is Ashka Makaria from New Jersey. She's going to show us the periodic table. Ashka Makaria.
Hi, I'm Ashka Makadia, and today I'm going to be talking a little bit about the periodic table and one element. So the periodic table has 118 elements. There are 11 gas elements, 6 liquid elements, and around 95 metal elements. So I'm going to be talking about hydrogen. So hydrogen is the first element in the periodic table. It was discovered in 1766. The discoverer was Henry Cavendish. The atomic number is 1 and the symbol is H. The element category for hydrogen is nonmetal and the atomic mass is 1.0079. Hydrogen is the lightest element. Its melting point is minus 434.49 Fahrenheit or minus 259.16 Celsius. Its boiling point is minus 423.17 Fahrenheit or minus 252.87 Celsius. Did you know that the National Balloon Museum says that the first gas balloon flight that was launched used hydrogen as the gas? Thank you.
I like the t-shirt, Ashka. That was a creative way.
I made it.
Oh, that's really nice. Okay, we have our last participant, which is Arav Hudka from North Carolina. He's going to talk about hovercraft. Arav, ready?
My name is Arav Hudka and I'm 8 years old. I go to Antioch Elementary and I live in Whitington, North Carolina. And today I'm going to make a hovercraft made out of paper. So first you have to get a square paper, then you have to bend it in half. And then you have to bend it into another half.
And then you have to unfold it and then fold it down so it look like a paper kite. And then fold the paper out. And do the same with the other side. And then flip it over. So then it's finished. And then you have to blow into it.
Just do the other side.
It doesn't really work. Doesn't really work.
Blow it hard.
Yeah, it works.
Do you have any ready which you made previously?
Yeah.
You can show in that one. That's fine, Haru.
This is a small one.
Well, you have the entire family. That's awesome.
You can from afar. Just show it from the other end, please. This is it.
Yes, now better. Yes. Wow.
That's it.
Thank you.
That was very nice, Haru. Thank you so much. We can all make something like that soon. All the kids did amazing, but before I say anything, we have the KPSNA president who were joining us today, Sanjay Kalavardia from Connecticut, and I request him to say a few words for all the appreciation for the kids.
Thank you, Khushbu. As you mentioned, my name is Sanjay Kalaria. I'm from Connecticut. All you kids have done such a great job. You all look so cute. All the projects that you have done, I personally learned a lot from that. And I just want you to keep working on bigger and better all those science projects and just make your name for your family, your school. Great work, everybody. Thank you for making me part of. Thank you.
Thank you, Sanjay Bhai. We also have Alpesh Bhai from KPSNA. If Alpesh Bhai can say a few words. All the kids were amazing, so if you can say something.
Certainly, yeah. This whole program was really amazing, and thank you, Khushbu, for arranging this one. And yeah, I mean, by looking this project, many times we are thinking that we never got chance in our childhood to make all these things, except the one which Arav Hudka, I think, last, right? That we used to do that thing, right? So yeah, but it was amazing. Thank you all kids, and keep doing this, as Sanjay Bhai said. And thank you parents for making them participating in this program, right? So they get some exposure. It was a really nice program. Thanks.
Very nice.
Alpesh Bhai. I think all the parents, as Alpesh Bhai said, was biggest part of this as well too. I have two little ones, and I know when you tell them to do something, there is a pressure and stress and what do I do and all the answers and whatever you suggest, they always not like it, and you have to come up with something everybody likes and then execute it very efficiently. We are done in an hour, which is amazing. We like to keep the program short and sweet and efficient and just give the arc of the program. So that's what happened today. And thank you so much, everybody and all the parents. And we'll bring something educational again. Now we all know, even President and everybody would agree that we have a very bright future of Kadwa Patel Samaj. Everybody's brilliant. So when you guys grow up, I'm sure our community is gonna be shining even brighter when you guys take over the community. So thank you so much, everybody. Again, I'll mail you the certificates via email, and it will be one more certificate in your whole pile of certificates, I'm sure. Okay, have a good day and good luck for your school starting soon.
Bye-bye.
Thank you.
Bye,
Bye.
Bye, everybody.
Thank you.
Bye, everybody.
Bye.
Bye. Thank you.
Bye.